Right, so in this video, we're going to be looking at how to solve trig equations. An example of a trig equation is something like sine x is equal to 1 over 2. And essentially, we're trying to find this x value, this angle. So the way we'd go about finding it is say, well, x is equal to the inverse sine of 1 over 2. Okay, this means this is the inverse sine, and you just plug this into a calculator. So the way you use the calculator is you see the sine, cos, tan functions on your Casio calculator, right? To find the angle, what you want to do is press the shift button first, and then you press the sine button, and then you type in your 30 and press equals. And if you press equals, you should get a value of 30 degrees. Okay, so that's how you go about finding angles using a calculator. Well, anyway, this is the solution for this particular equation. However, there are actually many solutions for this particular example, because if I were to draw a sine graph, which we learned in an earlier video like this, and so I'm going to just draw like a couple of waves like so. Essentially, what this is asking us is to find when does it hit this line, whereas y is equal to 1 over 2. And as you can see, there's many points where it hits 1 over 2 where they intersect. So there's this point here, this one, this one, this one, this one, this one, and many more if I kept drawing it, right? So essentially, there's very large numbers of solutions. And so what we need to do is find every solution. So as I said, there can be many solutions, right? So that's why in the question, they will give it a limit of a certain domain range where x can be. So you might see next to the question that x is between 0 and 360. This is the way of just limiting the number of solutions that we need to find. So we know that this part is 360 right here. So essentially, we're just trying to find a solution within this range here. And as you can see 2 solutions here. So we're trying to find 2 solutions. 30 degrees is one of the solutions. So this one will be 30 degrees. But now it's just our goal to find the second solution as well. And the way we do that is drawing something called a cast diagram. So a cast diagram. And that is just a quadrant with labels C, A, S, T like this. And that's why it's called a cast diagram. And what this diagram represents is it represents which trig terms are a positive value. Okay? So you're going to essentially draw 2 lines in 2 of these quadrants depending upon the question. So if I draw a line here, it just means A stands for all the trig terms, sine, cos, tan, are positive. This quadrant will be the sine terms only positive, T stands for tan, and C stands for cos. So depending upon where the line is in, it's going to determine which trig function is a positive value. So if we go back to our initial question here, it said that sine x is 1 over 2, meaning that sine is a positive value, right? So when we look at the cast diagram, we should be drawing a line in the sine section just to denote that it's a positive value. And also the all section, because sine is part of all, right? All is all 3 of these trig functions. So whenever you do this, you always want to try and draw 2 lines, okay? Determined by what the question is asking. Right, after we draw these 2 lines, now we look at the angle we got from the calculator, in this case 30 degrees. And this 30 degrees is the angle relative to the nearest horizontal line, okay? So these vertical lines, they don't really matter. It's just there for, these ones here, they're just there for just determining the quadrants. We don't really use them at all. The more important things is this horizontal line here. So as I said, the 30 degrees determines the angle relative to the horizontal, the nearest horizontal. So for this line here, this specific line here, in the all section, the nearest horizontal line is this one here, right? So the angle between that and the nearest horizontal line is going to be 30 degrees. For this line here in the sine section, the nearest horizontal is the left horizontal. So in this case, this is going to be 30 degrees. So this is what we'll be labeling. Right, next step. We now have to find these angles. So what we do is we start off at 0 degrees. So 0 degrees is determined by this first horizontal here, 0. And in this cast diagram, when we are going anti-clockwise, we are going to be adding values. When we're going clockwise, we are going to be subtracting values. Okay, that's important to note. So first, from 0, the first line is in an anti-clockwise direction, so we're going to be adding a certain angle, right? So x is going to be 0 plus the angle which we found was 30 degrees. So that's going to be our first solution. The second solution, as we said, is in this sine section, this one here, right? So we always go relative to the nearest horizontal line. So the nearest horizontal line is this line here, right? And if we go 1 for half repetition, half a circle, semicircle, it's going to be 180 degrees. So we start off with 180. But to reach the line, we have to go in a clockwise direction, right? So that means we're going to be subtracting a certain angle, and in this case, the angle will be 30 degrees. And that's how we find these solutions. So the solutions for x will be 30 degrees and 150 degrees. like this. Okay, so this is how you go about solving trig questions. Let's try another one. So let's try maybe tan x is equal to -1. And let's say the domain is x is between 0 and 360 again. So first things first, we find what x is. So x is going to be the inverse tan of -1. And we just plug it into the calculator, shift tan -1, which will give you -45 degrees. Next step is to draw the cast diagram. So we go like here, label it CAST, and then we draw the two lines which the angle lie in. So this is determined by whether tan is a positive or negative, right? So as you can see here, tan x is -1, so it's going to be a negative value. So we can't draw it in this T section because if I draw it here, it means tan is positive, so it's not going to be in that section. And so therefore I have to draw it in the sine section, S section, and the C section, like this. That's where we draw the two lines, okay? Remember, it's all because of the tan x is -1. That's because the angle is negative as well. It's not determined by that, okay? So you don't determine where it lies by the angle, but the initial question. Right, from here we label the angle. So in this case, it's relative to the nearest horizontal, right? So this one will be 45, will be this angle here, and this one will be 45 in this angle here. So it's never the vertical line in the middle. Now we go about finding it. So x is equal to, starting off with this one here, this is 0, but there's no line in this quadrant here, right? So we don't care about that. So we look at this line here, this vertical, 180, and we're going in a clockwise direction, so we're going to be subtracting 45 degrees. If we keep rotating, once you do one whole rotation, right, it's actually 360 degrees, right? So this section here, it could be 0, 360, or multiples of 360, essentially. So we start off at 360, and we're going in a clockwise direction, so we're going to be subtracting 45 degrees again. So now it's just a matter of simplifying, so you get 135 degrees and 315 degrees as our two solutions. Okay, let's try one more. So let's try maybe 3 cos theta is equal to √5. And the domain I'm going to say from -180 to 360. Okay, so that's the domain of our theta values. So first things first, we have to use the calculator, but what you should notice is there's actually a 3 in front of this cos theta, right? And we can't immediately put it into the calculator. We can't do inverse cos straight away. What we have to do is divide by 3 first. We do cos theta is √5/3 first. So there can't be any values in front of our trig term. Now I can do inverse cos √5/3 and plug it into a calculator, and you should get a value of 41.8 degrees. Next, we draw our cast diagram. So we have CAST, and we draw where the two lines are going to be. Because as you can see, cos theta is a positive value, so I'm going to draw it in the all section where it's all positive, and in the C section where cos is positive. And the angles relative to the horizontal, the nearest horizontal will be these angles here. So this one will be 41.8, and this one will also be 41.8 degrees. Now we look at the domain. So the domain says it's from -180 to 360. So we start off at the -180 side. So -180, remember this was 180 here, right? But if we minus 360, this can also be -180 as well. Right, so we're going to start off at this position here, and then we're going to go in an anti-clockwise direction, in this direction. But the first one we meet is this line here, and that line is closest to the angle 0 degrees. So the first value of theta is going to be 0. We're going to go in a clockwise direction, so you're going to be subtracting 41.8 degrees. The next one is this line here, so once again 0. But now we're going in an anti-clockwise, so we'll be adding 41.8. And if we rotate again, if we go one full cycle, this now becomes 360 degrees as well. And we therefore have to do 360 minus 41.8 because that's another solution. You could say, oh, 360 plus 41.8 as well, so you can keep going, right? But this value here, this is 401.8, is actually bigger than this maximum domain part here, right? So this can't be a solution. You can't include this in our solution. But now once you calculate all this kind of stuff, you get theta is minus 41.8, 41.8, and 318.2 degrees as our three solutions. So you have to be very careful of the initial domain that they give us, the range of our theta or x values, and make sure you find all the values within that domain. Right, let's try something more difficult. So let's say we have tan 2 theta is equal to √3/3. Okay, and theta is between 0 and 360. Right, so the moment that we see it in a trig term, anything other than theta, we have to include a step before we do inverse tan. And the step is we say let capital X equal whatever it is within this angle here. So in our case, it's 2 theta. And then therefore, we replace this with tan x is equal to root 3 over 3. It's a very important step we do before we even start completing or start trying to do the question. Once we've done this though, we have to change the domain as well, this theta value. Because this is the domain for our theta values. We have it in terms of x. So we need the domain for x. And the way we do it is, well, the relationship between x and theta is just 2 theta, right? So you just have to multiply 2 to each, the lower limit and the upper limit. So 2 times 0 will be 0. 2 times 360 will be 720, like this. That's the domain for x. It's important that you set this up as well. But now the steps are the same. So now x, we do inverse tan, root 3 over 3, like this. And you should get a value of 30 degrees using a calculator. And then we draw the cast diagram. CAST. Tan is a positive value here. So it's in the A section where they're all positive, and in the T section where it's all positive. But these are 30 degrees and 30 degrees. So remember, this is still, we're still solving for x, right? So x is going to be, the first value here is 0, because we're starting off at 0. And it goes 0 plus 30 degrees. The next horizontal will be 180. 180 plus 30 degrees. And then this is 360. But you should note that it's up to 720, right? So let's do another cycle. So we have to keep going again. So we do 360 plus 30 degrees. This one will now be 540 degrees, so 540 plus 30 degrees, and we stop here because that's the limit of the range. So x values will be 30, 210, 390, and 570 degrees. So we found the solutions for x. But initially, we're trying to find the solutions for theta, right? So we need to change it back into theta, and the way we do that is look at the relationship between x and theta again. It said x is 2 theta, right? So therefore, theta is just going to be x over 2. So to find theta, we just have to divide every single term by 2, essentially. So you get theta being 15, 105, 195, and 285 degrees. So anything other than a theta value in our trig equation, we have to let x equal to it, change the range, find the values for x, and then find the values for theta. Let's just try one final one. So let's go for maybe root 3 sine x minus 60 plus cos x minus 60 is equal to 0. So we're trying to find x again. As you can see, it's not just x, so we're going to introduce a capital X later on. But first things first, we just need to rearrange this just to get one trig term only. So I'm going to bring the cos to the other side. So root 3 sine x minus 60 is equal to negative cos x minus 60. And what I can do now is I can divide the left-hand side by cos x minus 60 and divide the right-hand side by root 3. Because we know that sine over cos, the identity sine over cos, is tan, right? So this will reduce to tan x minus 60 is equal to minus 1 over root 3, like this. Now, as you can notice that we have just not an x on its own, so we have to say let x equal to the angle, in this case small x minus 60. So therefore, tan capital X is going to be negative 1 over root 3. And remember, let's say the domain is 0 to 360. We have to change the domain for capital X. And the way we do that is just minusing 60 to each limit side here. So for capital X, it's going to be negative 60 until 300, like this. It's important you include this step here. Now we can use the calculator. So X is equal to inverse tan minus 1 over root 3, which will give us negative 30 degrees. And we draw the cast diagram. CAST. Remember, tan is a negative value. It's not because of this one here, it's because of the tan value here. So we draw in the S section and we draw in the C section, where this is 30 and 30 degrees. Right, we have to note where we start off with. We start off at minus 60 degrees, right? So we're going to start off at here 0. So x is equal to 0 minus 30 degrees. The next one will be 180. So 180 minus 30 degrees. And if we go to 360 again, we go 360 minus 30 degrees, but this has become 330, right? And this is bigger than the upper range, so we don't include this one here. We can't include that as our solution. So for capital X, it's going to be minus 30 degrees and 150 degrees, like this. But remember, we're trying to find small x, and we know that big X is equal to small x minus 60. So small x is big X plus 60. So the values for small x will be 30 degrees and 210 degrees, like so. Okay, so the main steps are the same. It's just a matter of just manipulating in the initial steps or the initial equation to get one trig term, and then replacing the angles with the capital X. It doesn't have to be capital X or whatever letter you feel is suitable.